This is our distillation trainer here at Red Deer College. This video is going to provide you the information you need to complete the pre-lab questions for the distillation control lab. So first things first, I'd like to identify that we do have methanol here in our feed tank. You can see this label on the tank. So we have a mix of methanol and water that go into our distillation trainer. It gets separated and then it is fed back to the feed tank in a closed loop system. The other hazard that I'd like to identify is over here. We have three-phase power. We use three-phase power to energize our reboiler on the bottom of the column to produce all of our heat. When you're completing the lab procedure, you will have to ask the instructor to come over and turn on the main disconnect for allowing you to run the reboiler. Now I'm going to move you over to, we're going to pull a sample off of the feed pump and demonstrate how we figure out the concentration of methanol in the feed. Over here on the back side of our distillation trainer we have three pumps. This first one here, P301, is our feed pump. P302 is our bottoms pump. It pumps the liquid off the bottom of the reboiler. And then P303 here is used for reflux. When you obtain a sample from the column, you're going to be pulling a sample off the reflux pump. Right now I'm going to demonstrate pulling it off of our feed pump. I will need to start the pump up to do this, so I will do that now. Alright, so I have P301 running. I'm going to take a sample from this ball valve right here, this Swiss-like tubing ball valve, and put it into a graduated cylinder. And then we are going to drop a hydrometer in there to figure out the specific gravity of the feed. So we'll go ahead and do that right now. Okay, so here's our sample that I pulled from the feed pump. You can see it's kind of pinkish in color. That's because we have some red food coloring that we put into the feed. Red food coloring stays with the water, so you can expect that most of the sample is going to be water. I have a hydrometer sitting in there, you can see. I'll try to bring you guys in close. If we look here, we've got some divisions, bigger divisions here off to the left that are in specific gravity. This hydrometer goes right down to a specific gravity of 1. And our sample is going to be anywhere from between 0.998 for 0% methanol. That would mean it's all water. All the way up to 0.792. If it was a specific gravity of 0.792, we could infer it was 100% methanol. We only have two products in our mix. We have methanol and water. If it was all water, we'd be down here at 0% methanol. And if it was all methanol, 100% methanol, our concentration, you can see onto the right there, it would be a specific gravity of 0.792. And also take note, this is at 20 degrees C. Specific gravity is affected by temperature. Our sample was taken at 20 degrees C, so we don't have to worry about any correction or anything like that. And when you do the lab, we're going to be pretty close to 20 degrees C when you do the sample there as well, so you do not need to worry about any temperature compensation. So let's have a look here and verify that our specific gravity is 0.966, like I have written on the board over there. We'll zoom you guys right in here. You can see that we get the larger divisions separating. It's going up by a hundredth of a specific gravity. So at right between 0.970 and 0.960. If we move over to the right here, we've got smaller divisions. Each one of those divisions represents 2,000ths of a specific gravity. So we can see about two divisions between 0.970. So that means we're probably at about 0.966 for specific gravity, because there is three divisions above the water, or sorry, the sample, which would indicate that it's about 0.966. So that's our reading. That's what we've written up on the board here. Now we can use a simple input-output calculation to convert this into a percentage. We're going to be going from this specific gravity range over here on the left to our percent concentration over here on the right. So let's use the input-output calculation. You can I have it drawn on the board here already. You can see we've got our percent methanol is what we're determining over here. Our sample specific gravity right here in green. And we have to subtract our lower range value first from it. And then put that over our span, which is our upper range value minus our lower range value, specific gravity. Multiply it by the span of our concentration and add the lower range value of our concentration. Works out quite nicely because our lower range value and our concentration is 0. So the calculation simplifies down quite quickly to just a simple division multiplied by our 100% upper range value, which is actually our span. And we figure this all out to be 15.5%. We do our subtraction here, and then division, multiplication, 15.5% methanol in our feed mix. So this calculation will be needed to determine a few sample calculations on the pre-lab, and then when you are in the lab you will be doing you'll be determining the concentration of methanol in the TOPS product, and that will be you'll have to get your instructor to help you pull a sample, and then you'll use the same method here using the hydrometer to figure out the concentration by inferring it through the specific gravity.